Welcome to malware analysis for hedgehogs. Most people think when they analyze a file that the overall result of that can be one of two possible outcomes, which is either it's malware or it's clean. However, there are actually 6 or 7 possible outcomes. And these kind of outcomes or short words for an analysis result are called verdicts. Today, we are talking about verdicts in antivirus context, so I'm specifically not discussing EDRs here. So what is a verdict actually? Maybe we should start with that because it might not be immediately clear. If you receive a file as a malware analyst, you don't know if it's malicious or something else. You write a report after your analysis. So it could be 5 sentences or 200, no matter what. But if you could have one word to describe your analysis result and to summarize it, that is the verdict, this one word. And this word answers 4 questions immediately. It says, should the product, the antivirus product, detect it or not? Should the file be put on an allow list? And is it risky to use it? Is it dangerous to use it? The first verdict we are going to discuss is the clean file verdict. And clean files are actually an exclusion verdict. So if none of the other verdicts fit to this file, then you can call it clean. We associate with clean files that these files are safe to use. They don't cause any damage or harm. And in most cases, they can also be allow listed. There are some exceptions to that. For instance, if you have standard execution environments like PowerShell exe, you should probably not blatantly allow list everything that happens in there because these are execution environments. They can be used to execute malicious code. But they are also standard components. So just like the operating system can run malicious code, it's still a standard component and also considered clean. The next verdict we are going to discuss is junk or corrupted. So these are 2 categories, but it usually doesn't make sense to determine whether it's one or the other. So there can be areas where you don't know for sure, is it corrupted or is it rather junk? And it would take a lot of effort to distinguish those two. So what's junk? Junk is a file with no apparent purpose. It could be a very trivial file that's empty or that's filled with 0 bytes or where you just have a random blob of data without any context. But you can also have corrupted files which are corrupted in a way that they cannot execute. So this is very important. Corrupted does not mean I have a file here and when I double click it, it just closes itself immediately, so it's corrupted. Or it shows an error message that a certain library is not there that it needs. So you need to be sure that the corruption is making this file in no circumstances executable. So if you just don't provide the correct environment, that's your fault. That doesn't have to do anything with corruption. But if, for instance, a file is truncated in a way that the executable section is completely gone, then no code can execute it. Like if the entry point is in a virtual space and nothing can execute there. Or if the PE file signature is zeroed out, then it would require some repair program to make this program run. But until that happens, it's a corrupted file and nothing can happen. So there's no danger from these kind of files. And that's basically it's also not important. That's what you tell them with your verdict. The next verdict is phishing. So phishing has actually its own category, and that makes sense. So with malware, you associate malicious software. That's the abbreviation of malware, right? So you associate some sort of code that does malicious stuff when you double click on it. And with phishing, you have a document that scams the user into providing private information that they shouldn't provide to this third party. And this is kind of a little bit, let's say, a different danger category. So with phishing, yes, you want to stop this with the antivirus product, but it's not as dangerous as an actual malware when you double-click it. The next verdict is pub. Now, pub is actually relatively complicated to distinguish exactly, but the general idea of pub is pub means potentially unwanted. It is something that some users want to have on their system, but most users don't. And it's always legal software. So you have an actual company that produces the software and that sells the software, and it's allowed to do that. These pub verdicts are sometimes the hardest to do because the companies will complain a lot and they will try to convince the AV companies to remove their verdict. And there sometimes is legal battle involved. So this can take a long time and a lot of work to establish these pub detections properly. And but what's important to know here in general, so we have started to distinguish between riskware and pub. So riskware is the next verdict I'm going to explain. In the past, riskware was also pub for us, but we decided to change that because with pub, we always associate a low severity. There's no danger involved. It's usually just annoying for the customer in form of ads, browser hijacking. It could also be like something useless, like a system optimizer that will tell users on a freshly installed system, oh, there are 200 warnings, and exaggerate that there are problems on the system unless they buy their software. So shady stuff like that, or it's like software bundlers where you are tricked as a user to agree to certain things. They may hide an opt-out checkmark somewhere where you have to scroll down, or it may be in a color that you don't expect, like light gray that you barely see. It might be hard to find. So there can be all kinds of tricks how they get you to agree to install additional third-party software, and that's also pub. But if that's found on a system, it's usually something where, well, no one is worried. It's just annoying. And I should add, someone asked me if adware is always pub then. If it says adware in the detection name, yes, that's a pub detection. However, adware is not the same as pub. Ads is just a symptom, and it can also stem from a malware. So some malware will provide ads. The difference between a malware that provides ads and pub that provides ads is that pub is a legal company. So they usually provide some sort of useful software behind it. But if you just make, let's say, a program whose only purpose is to hijack your browser and provide ads, and when there's no useful purpose behind it, none at all, it's malware. It's a low severity malware, but it's still malware. So what is riskware then? Riskware is also legal software. However, it's legal software that is usually, not usually, but that's very often abused by threat actors to compromise a network of a company, for instance. So it might be used for lateral movement, but it might at the same time be a tool that that administrators use to manage their systems. So it really depends who uses this tool or this software, and if the person has good intention and if the person is supposed to be there and do these things. So if it's not the case, then you have an actual problem there. Then you have threat actors in the network. And if it's an administrator, it's just fine. There's no risk involved. Sometimes also remote access tools are considered riskware if they allow abuse very easily. So they might have an option where they are totally silent to the user where you connect to. So if you can just implant it as a remote access malware, basically, that's hidden, that's not visible for the person on the other end, then it's also considered riskware if they don't take proper care that consent is involved in the remote execution. So the next verdict is a little bit difficult because it catches a lot of different things under one umbrella, and that is Grayware. So Grayware, in short, would be everything where you would feel yucky to call it clean, but it's not actually malicious, and it's not phishing or pub either. So what could that be? One category that falls into that is cracks, simply because they are illegal. Everything that's illegal and that's not malicious, that's considered Grayware. Furthermore, that includes also, for instance, child abuse material. So I don't know why, but some customers think it's a good idea to send us child abuse material and demand that antivirus companies detect it. If you ever thought this is a great idea, it's not. You just traumatize the analysts that work on these tickets. And we do not detect such files, at least not on purpose. And all that we do is we have to clean up our databases from these files because keeping them is illegal. So what else is there that is considered Grayware? That's, for instance, ICAR. ICAR is the standard antivirus test file. And ICAR is not malicious, doesn't contain any malicious code, but every antivirus software is supposed to detect it. So where do you put it? It doesn't fit the malware definition. It's Grayware because it would not be correct to call it clean. With clean, you always have the assumption that there is no detection involved on this file, right? So it cannot be a file that's used for testing antivirus products. And there's more like ICAR. Things that are like ICAR, for instance, is any kind of malware simulator or adversary simulator, things like that are not actually malicious, but that are supposed to test the product, or where they are used to train people who work with these kinds of stuff. So they see, for instance, how a ransomware looks like on their system, then you can execute ransomware simulator and know what it feels like. And the odd thing about this is you can never make it right. So some customers will demand that you do not detect this because they actually want to see how the ransomware works. And others will demand that you detect this because it behaves like ransomware and they were testing your product with it. And no matter what you do, it's wrong. You will always have someone complaining about detecting or not detecting it. And that's Grayware, basically. Sometimes you also have files where you really don't care if they are detected. These can be, for instance, files that belong to a malware. So they are but they are not a dangerous part of the malware. So one thing that we consider Grayware is ransom notes, for instance. Ransom notes that are only text files or pictures. We do not detect those. Some antivirus companies do. Also here, it's kind of on the basis, so some people feel like their system is very dirty. If there is remnants of the ransomware, they want the antivirus software to clean everything. But a lot of people want to keep the ransom notes because they contain important information in case you want to pay and get your file back. So for us, it's the case, it's Grayware, but we do not want to detect the ransom note, so we usually fix the detection. So with Grayware, it's never quite clear whether a detection is something that is wanted or not, and you always have to specify that when you make a verdict like that. For all of the other verdicts, it's clear whether there should be a detection or not. So the QA knows exactly what to look for. For Grayware, that's a different matter because it's such an umbrella term of stuff you don't want to call clean. Another thing that I forgot is files that have been infected by viruses and cleaned afterwards. Something that happens quite often, that such files get submitted because some companies, they may buy our product and suddenly they have virus detections that appear that weren't there before because the previous product that they used cleaned those files, but there might still be virus code in them that's just not accessible from the actual execution of this file. So usually a lot of viruses, they change the entry point to the virus code, and if the cleaning product just changes the entry point back but does not remove the virus code, you still have virus code in it, and detecting it is actually something that you want. So even if those files cannot really execute anymore. So calling these files malware is wrong because they cannot execute the virus code, but calling them clean when there is still virus code in them is also wrong. So that's why it's also grayware. The last verdict is the most difficult to explain, and that is malware. So why is it so difficult? When you make a definition of what malware actually is, in practical use, you will realize that there are always some more exceptions that don't exactly fit into this definition that you created, and you need to add more categories to it. And so the most easy category is probably that you have code that is doing harm or damage to a system. Now, we have a lot of explanation what makes damage, something damaging or harming. But to give some examples, it could be a systemic damage where the system files are actually like overwritten or deleted. It could be that files are locked or encrypted, like from ransomware, and the user cannot access it again. It could be financial damage, so stealer, coin stealer, banker, they cause financial damage. So these are just some examples, but it could also be psychological damage. If you have a ransomware that extorts you to pay something, and it's a program, right? But it just fakes that an encryption is happening, and it demands that, let's say it just renames your files, right? So most people would be tricked into paying to get their files back if the files are just renamed. So this is already considered malware, even if it's not actually encrypting. The actual working encryption is not a prerequisite to call it malware. Just the intention counts. And that's the second category. If something intends to do harm, and it's clearly an intention there, it might not work, for instance, because there's a bug, but still you want to detect this kind of file. Maybe the bug gets fixed next time, and you still want to detect this kind of file as malware, right? So there's no reason to put it into any of the other categories just because it doesn't work. Then you would have to test whether the file actually works in all circumstances. So no, that's way too complicated. It intends to do harm, it's malware. And another category is anything that allows unauthorized access to a system. So a backdoor, for instance, a web shell doesn't always have to be full-fledged remote access software. It can also just be a small web shell that allows you to access it. And here it doesn't matter if an actual intention of harm was there or if a person ever used this backdoor, it's still malware. So unauthorized access, malware. Let me check my notes. So the next category is like one of the exceptions that we encountered is archive bombs. Like, where do you put them? They don't have any executable code. You just open them and then they fill up the disk, right? But they are widely considered malware. So what we said is, okay, if a file has characteristics that lead to physical or systemic damage of a system upon viewing or opening or extracting them, then it's also considered malware because they have been crafted in a way to do that. And even if it's not on purpose, if something causes harm, actually causes harm, and it was not on purpose, it's also malicious. So like the Morris worm, it wasn't supposed to cause any harm, but still it was very dangerous and caused a lot of issues, right? So this is also a category. Then you can have executable code that has the purpose to hide an infection. So you have rootkits, malicious rootkits. Rootkits are not always malicious, but if they are, if they hide an infection, then they are considered malicious rootkits. If they facilitate or persist an infection, it's also malware. And last but not least, you have the category of containers of malware, because a container of a malware that you can extract or that directly executes when you double click it, like self-extractable archive, for instance. You double click them, they execute the code and then unpack themselves and execute what's in there. So those are also malware, of course. And also if you have a container that you can unpack with any legitimate software, then you have the danger that a user may also unpack this and then open it. So you want to prevent this from happening, and it's considered also malware because of that reason, because you can unpack it. This is to distinguish from, for instance, files like steganography. Like if you put a malware file encrypted and hide it in an image, and you do it like in a way that it can never execute if you open this image, that the image is basically harmless. This image is considered Grayware. It's not malware. It's usually not detectable if the malware is encrypted in there. What you can detect is the second part that will extract the data from this image and then execute it, but you cannot necessarily detect something that's encrypted as a whole. So where there is no executable code inside, right? And no harm, actually, unless there is a second component. So yeah, this is to distinguish these two. There's the other category. So, and that's it. And these are all of the verdicts. If you have any questions, please let me know. Maybe this was news for you. And if you do it differently, if you work for, let's say, an AV vendor or EDR vendor and you have other categories, let me know. I would love to hear about your views on this matter.